Okay, so let's talk about our kind of just a starter linked list, right? Just add front and what, get front? Not even remove it, just look at the front. So just some practice with structs, that kind of stuff. All right, let me open this. All right, so if we think about our linked list, historically we've created a class called a node or something like that, right? So maybe in here we're going to create a struct called node, something like that. And for a linked list, each node needs to have its payload and then also needs to know about its next node. So it needs to have a pointer to the next struct in the list, correct? So we'll have an int payload or whatever you want to call it. And then we'll have a struct node pointer next node, something along those lines. All right. And that without capitalization and stuff. It's a keynote thing. All right. My phone's blowing up here. Oh. Probably just Van flipping out about a senior project. I thought it was like my wife or something. Something important, you know. Okay. So we're going to have this, and then we're going to build this into just a normal plain Jane file. So let's just start a fresh file here. Let me get rid of the shared memory stuff here. Okay. New file. We'll go ahead and save this, and we're going to call this C linklist.c. All right, so we'll do pound include standard io.h. Leave it at that for right now. We'll say int main, int argc, char pointer argv. All right, then we need to give ourselves our struct up top here. All right, so we're going to have a struct called node. And this guy's going to have an int payload and a struct node pointer next node, something along those lines. Now we don't need to have, I mean, we could create a variable here, maybe called head or something like that, but we'll just start it like that. We'll just give ourselves the deal here for our node. So we're going to have some functions in here that allow us to do some things to our linked list. So let's just start off here in main, and we'll go ahead and we're going to create a struct node. Call this guy head. That'll be the head of our list. And so initially, head is going to have a next node that's equal to null. Probably does default. So actually, it's null, capital N-U-L-L. That's going to require us to import something up there, right? So we'll go ahead and say head dot next node is equal to N-U-L-L. You better remember, what is that, standard lib? Where does that live? So I think, huh? Yeah, I think. Are you sure? I thought we compiled it one other time. GCC C linked. This is all legal code, right? That's the name of my node, head.nextNode. It's a disaster. We'll just go over to Cloud 9 in a second if this doesn't work. It's just my GCC is broken. Oh, you know what? I bet you. Let me just do a sudo here. Yeah. It didn't have permission to write to the desktop. Don't you store all your source code stuff in the desktop? is that where you put it? All right. All right. So let's just make sure null is available now. Okay. For some reason, I thought null was stored in another library.
Maybe for like older versions.
Yeah. Well, whatever. All right. So we'll create our head node. Then we'll set the next node in there to null, which is probably what it would be by default, but let's just be explicit there. And then we want to write a function called add front, right? Now, actually, probably the smart thing to do here would be to say head like this. Give myself the variable up there instead of defining it here. Why is that?
You have access to it.
Yeah, that's kind of as a global variable for all the places. I don't have to start passing the head of my list around. So more of a convenience thing. But in main, we'll still go ahead and give ourselves the, we'll set the next node to null explicitly. Okay, so now we should write a function called add front. And that guy can be void. We don't need to return anything from that. So we'll say void add front, and this guy will take in an int payload. All right, so the very first thing we'll do is we'll go ahead and create a new instance of our, well, it's not actually an instance, but create a new struct of type node. So we'll say struct node n. We'll say n.payload is equal to the payload we just passed in. And we'll say n.nextNode is equal to null. Again, just explicitly set it to null. Kind of the thing we would usually do in our constructors. So we're almost seeing kind of the rationale for why we need why constructors are helpful in objects. Otherwise we have our wires kind of laying out here. So if this goes way back to when we talked about the procedural version of a telephone with a big pile of wires here on the desk, and if you took my 200 or 250 class, we usually talk about it in there. I think everybody in here had that. So the stuff that would usually go in the constructor, we kind of have to just have out here laying the wires just visibly laying out here. All right, so then we need to ask the question, where do we put this guy? All right, so if, now in actuality, so we'll say that what we might do here is we might say if head dot, see, really head shouldn't even exist at this point if we're looking for it being the empty list, right? So how can we ask the question if head is currently nothing? Because if we're adding this to the very first element of the list, that means head's next node would be null, but that's entirely possible in a list that already has one element in it. In fact, that's exactly how it would be in a list that already has one element in it. So how can we ask whether or not this is the very first element in our list?
Head will tell you what's his next. It's not
Right, but if you have a one list, so if we come in here and we draw a picture, the empty list would be a list where head literally points nowhere. Where the one list would be a list where head points to an actual node struct whose next node points nowhere. So if we're looking at head's next node, in this case, if head is already a struct that exists, his next node is null, right? Whereas in this case, if head points to a real first node, this guy then points to, this guy goes to the front of the list. Or, I'm sorry, if there's actually a real first node in here, his next node would be null. So at that point, if you're checking next node, these guys would fire the same way. They would look identical. So we really need to have that idea of an empty list. Go ahead.
Or what does it matter if we check if head's null at all? Because if we declare head is null and then add one to the front, just pass the next one as head, and then we'll make the first one point to null. And then you can just keep going through.
Well, the issue here is that because I've used this syntax here, I have a variable called head that is equal to a struct, right? I can't set that guy to null because I actually have the front of the list called head. How can we get around this?
Check if the payload has a value.
Could check if the payload has a value. The default value would be 0 though, right? Is that a legitimate payload?
Yeah.
So what if we don't create that, but instead up here we create a struct node pointer called head? And then in here we say head is equal to null, which is probably the default value of it. So that pointer does not have a memory address in it, right? Okay. So we just created a new node. We're going to ask the question if the value in head, okay, because head is a struct, right? If its value is null, and actually this would be, no. It's going to be a memory address that points nowhere, which means that this guy, we'd also say that. If head is equal to null, that means that variable holds the memory address null. Then we know we have the empty list. So if we have the empty list, then we're going to say that head is equal to, we want to say the address of n. Right? That's our new struct. All right. So we'll make head point to wherever the struct we just built was. Otherwise, I guess welcome message. I really don't like how Adam just basically remembers variables across all these files. I mean, that was something from our C program. But regardless, it's not. It doesn't make your life easier, does it? It's just garbage. All right. So if head is null, we'll just set head to point to. Well, head will equal the address of the node we just created. Otherwise, if head is something, we want to make head's next node point to the guy we just created. So we'll say head dot next node, which is a node pointer, a struct node pointer, will equal the address of n.
That's not going to add it to the front, though. It's going to add it to the second element.
Oh. This will add to the end. I'm writing add to end right now, right? So, call this add end. Rename this add end. Yeah, this would add to the end of the list. We want to add this to the front of the list. So if head is null, this becomes the new front. Otherwise, we need to say n dot set next node, which is the pointer, and that guy's going to equal head because head already holds an address. All right, it's not set next node; it's just next node, right? So n dot next node is equal to head, and then head, and we already have this guy have the payload. Then we'll say head is equal to the address of n. So we set n's next node to point to wherever head currently points to, and then we'll update head to now point to the address of n, which will put it in the front. What we did before would have added it to the end. Okay? All right. So that should be add front. Let's just run this a couple times. Let's just do add front 1, add front 2, add front 3. Okay, let's find out what we broke. Oh, it's not going to just remember. Oh, prototyping stuff, right? So I'll prototype my function up there. Seems to be okay. Seems to run. I have no output because it just added 3 things to the front of my list. All right, so now I want to be able to get. We just get front or get an index? What did I assign you? Because clearly I'm adding to the end and whatever. All right, so we have get front. All right, so we'll go ahead and write void get front. This guy will take no parameters. And just so I don't forget, let's go ahead and prototype this guy up here. All right, now remind me, why do I have to prototype these guys up here? Single pass compiler. Even though GCC is showing its hand here, notice it just gave us a warning because GCC is actually a 2-pass compiler. But since I think I'm running it in, what is it, C99. So add front is invalid in C99. It's telling you in an older version of this compiler, this isn't how you want things to fly. Okay, but the modern GCC is a 2-pass compiler. Or a multi-path compiler. It's entirely possible it goes through more than twice. But at the very least, it reads through one time, picks up all the symbols. Then at least on its second pass, it now knows about your function calls. Okay, but it's telling me that in the 1999 version of C, that wasn't a thing. Which is actually, I would have thought it would be even older than that. But, well, I would have thought by 99 they would already have a 2-pass compiler for it. Although that is pretty early on in the Linux world. Not super early, but Linux was only starting to get kind of popular in 1999. And GCC is GNU C compiler. So it's possible that, that was the advent of GCC was probably in those early days of Linux. So yeah, maybe they just didn't have 2-pass then. I don't know. Whatever. All right, so that's why I need to prototype these guys up here. So at the very least, when the 1-pass compiler flies by, it says, oh, I've heard of those guys. The implementation is then down here. All right, so get front is just going to look at head. This guy's not a void. He's going to return a struct node. I suppose you could have written it maybe. It's just printing what's there since it's not all that handy, but whatever. We'll have it return the node that's at the front without actually removing it. So this doesn't do anything specifically to the list. So get front, we'll ask the question. We'll say, actually, we could just return head. You know, we could ask the question if head is null, but bottom line is we're returning a node here. So if I return a null, I'm returning a null. So really, I could just do return head. It may or may not be null. That's the front of the list. All right. So then up here, I can say struct node temp is equal to get front. Now, we know that the head's not null in our case here. So the front should be 3. Now, in actuality, this guy's returning an actual node, not a node pointer. So I need to say, give me the value that lives at head. Right? Star head says, follow the memory address and get me the actual struct that lives there. Yeah, so we are dereferencing the memory address. Yeah, which says go and follow the pointer to the actual place in memory, follow the reference to the actual place in memory, and get me the value.
And when we use the end, the other symbol.
That says give me the address where something lives. Yep. All right, so I mean, we could have had this guy return a node pointer if we wanted him to, and then we could have just returned head, but then we would have had to deal with it on the flip side, right? You gotta dereference it on one of the sides, whether you get memory or you get whatever. All right, so we'll go ahead, and this guy's going to actually spit out the actual struct that lived at the front. So we'll return star head. So that allows us to capture it inside of an actual struct node temp. And then we'll just do a printf %d \n temp.payload. And that should, in this case, print out a 3, the first element of our list, assuming we always added stuff to the front. It's going to become very inconvenient. So why don't you move it from the desktop? I'm just it's a thing. Previous declaration. Oh, because when I copied it, it wasn't a struct node, it was void. When I prototyped it, I prototyped too early. And there's our 3. So does that solve the homework assignment? Pretty easy. Not too bad. Okay. So what if? Well, first of all, any questions about that? Yeah, we already basically wrote add end, right? That was my first add front was add end. It's very entertaining. Okay, so what if I wanted to actually have this guy live in another class and then bring it into this class? So I kind of want to write my own like linked list class. So I wrote it. I called C linked list, right? Okay, but what I want to do is I want to be able to use the functions from this class inside of another class. So I'm not kind of doing everything here. I actually would have all this stuff kind of be empty. So main wouldn't really have anything in it, right? In fact, I could actually omit main here. All right. So let's leave it there for right now. Because this is a program that runs and does nothing, but it has some capabilities to do stuff. All right. The name of my file is clinklist.c. Now what I'm going to do is I'm going to go ahead and I'm going to take my actually, I think I would do it for all of these. All right, so I'm going to take those things. I'm going to put them into a header file for clinklist.h. So I'll create a new file. Go ahead and save it, clinklist.h. I'll go ahead and slap that stuff in there. So those are all my prototypes. And then I'll come back into this guy. And just for a second here, I'll put that stuff back in there just so we can test it. Well, I wanted to get my logic back into main so we can test it. All right, so now I can go up here and I can include, but since it's a local file, I'll include clinklist.h. So I surround it by the double quotes instead of the angle brackets. Angle brackets say, here's the, this is a library that the GCC links against. This says, look in the local directory for this guy. Okay, so let's go run this, make sure we get the same stuff. Still happy, right? So now we have our header file for that guy. Okay, so now I'm going to go ahead and I'm going to get rid of that stuff there. And we're going to go ahead and we're going to create another file called test linked list or something like that. So file, new file. We'll save this guy. Test linked list.c. And we'll go ahead standard io.h. We'll also include C linked list.h. I technically can leave main empty like that if I don't intend to use any command line arguments. So just to save us some time, we'll go ahead and do that because I'm not returning a value anyways. In fact, you could also say that main returns void in our example here. I chose not to return anything in the previous one anyways. So that is kind of a difference than we're used to with like Java, where Java, main has to be called public static void main string array. Then you can name that last variable whatever you want. But Java requires that the signature for main looks exactly like that. Okay, where in C it is an optional thing, but if you call C with command line arguments and you don't have a place to catch them, it'll scream at you. Okay, because you don't have that count or that collection. You don't have the array of strings to catch it. Also, typically, and I've asked this in a previous class, why does main in C typically return an int? Somebody other than her. She answered it correctly last time. Go ahead.
Because everything returns 0, 0, 1, and in C, and that's
Why in C?
because if it works, return 0. Otherwise, the errors are like from 1 and incremental.
Who's typically using those C programs? I want to connect that last dot.
Operating systems.
Yeah, Unix really, right? So really, we're talking about kind of a coupling, if we want to use the software engineering term, between C and the Unix operating system and later the Linux operating system, where most of, well, really, I mean, I think it's fair to say all of the system calls in Unix were written in C. So when you call the system call, you might have you might have expected a return value that would be like an error code, right? A 0 if everything worked, a 1, a 35 if it was a very specific error, whatever it is. So main historically would have returned an int because that's what it would have returned if you were writing a Unix system call or a program to run in Unix, because you would want to know what the output of it was, whether it worked or not. It's kind of the punchline there. But in our case, since we are not actually going to return anything anyways, we can make it void. Although very early C compilers would have screamed at us, because the assumption was that, look, this guy always returns an int and this guy always takes in some number of parameters. Takes in an argument count and the collection of string arguments, because it was extremely common for us to pass that stuff. So if I go back out here to, for example, GCC is written in C. It's expecting a command line argument, which is the name of the file you want it to compile. All right, so the argument count, what would be the argc for this guy right here? The argument count. It's actually 2. Actually, I'm kind of lying to you right here. The argument, it would be the program name 2. So in this particular guy, it would be 2. It would get the GCC, and it would also get this guy here. It would get both in case you needed to check which program ran, if it was running against a library or something like that. All right, so we want to try to use our linked list stuff in here. So we should have access to our node, correct? All right, so we're going to go ahead and we're going to make a couple of calls here. I think I copy that stuff. I don't need to set head equal to null because I am, technically I didn't do that in there, but what I can do is, let's go here. Oh, I took out, that is in H. I'm going to bring this guy back in. That way I can default it to null. Here's my linked list. just so it has a starting value of null. All right, so I have all my wires hidden inside of my linked list class here. And then I can go ahead and start calling these guys. So I can add front. So where's my test? So I add front 1, add front 2, add front 3. Then I'm going to go ahead and get front, and I'm going to print it out. So we are now compiling testlinklist.c. So it's finding it, but it's seeing that I've, yeah, well, I need to move this struct into, let's do this. Take my struct. Let's move that into the header file. Test link list. I brought in clinkList.h. So that would make that struct available to me in here. I shouldn't have to link. I shouldn't have to link it against that. Undefined symbols for those two guys. I am doing sudo, right? Yep. Those should be found inside the header file. I shouldn't have to link against the header file, although it does want me to return an int here. Like I pointed out before. So just to keep things, let me go ahead and I'm going to do the int argv char pointer argc. I shouldn't have to link against my own header file. That's the way it's actually asking or acting. So if we go out here to GCC and we look at help, there's a -L. Actually, let me do this. Help pipe to yeah. grep on -L. Oh, I'm using. Yeah, I'm piping the output into grep. Grep is looking for a pattern. No, grep should do it. Whatever. So I'm looking for the L to link against stuff. Add directory to library search path. I wouldn't imagine I'd have to add the current directory. I doing something wrong with the compile? Yeah, here's functions.c, which includes functions.h. This guy has your implementations in it. Functions.h. Here's our prototypes. I don't think you have to do something like this. I'll copy it for right now. Main, just include that. That's like our linked list thing. And then you can just start using the functions. So that was in the header file for this guy. I'll explain what that is in a second. Let's just see if that is our fix. This guy, well, I mean, this didn't seem to be the fix, at least in this case, but this is if not defined. So if this guy is not defined, go ahead and define it. So it's just, it's kind of acting like this might be a global variable that is part of that. I'm wondering if this is, you're having the same issue on your Mac, right? Okay.
Mm-hmm.
I'm inclined to potentially move this over to Cloud 9, but this is pretty simple stuff. This isn't something that just shouldn't work on a Mac for some strange reason.
I don't know, it's 9.
Huh? Hey, oh, it is a Mac. Well, it actually is Unix that Apple partially broke. that's what it is. Try something along these lines. So this guy seems to relate to the name of the header file here. And then there's an end if at the end. So this would be linked list. And then we have the end if directive down here. So it says if this guy is not defined, then define it. So perhaps you could have named this whatever you wanted because we are defining it here. So we're defining it as this, and this is the closing thing for that end if. This is a preprocessor directive that's used by GCC. I still wouldn't think that this would be the... Because they're saying this is just guarding if you're using this header file on a lot of different things. So it says it can't find add front, can't find get front inside of this guy. I linked it right there. Let me just make a single call to add front to at least streamline our error messages. Let me I'm going to make a directory called linked list here. I wonder if it has something to do with I'm calling GCC with sudo. Although, are you having yours in your own directory without using sudo?
It's getting the same issues.
Same issues, okay.
One thing I'm seeing is, looks like it may be because, the C linked list.c is not getting compiled, and so it's not being able to pull that in. But I didn't read the whole thing yet. That's just.
Yeah, but it should auto-link against it and compile it.
I would think so, but.
Because the stuff is in the same directory, and we have this clinklist.h, and another guy. Oh, unless we're overriding our own a.out. Let's do a GCC on this. And let's just have our output file called TLL. Oh, I still had CD at the end of that. Nope, same problem. Can't imagine that we have to. Yes, we have this thing called a make file, which will allow you to build multiple files at once, but that shouldn't be a. That's really only for large projects where you have a lot of these things you have to do. It should link these guys. All right, so that thing I just looked at, it says you should do something like this. We should compile GCC. We'll do clinked.list.c. All right, so that compiled that guy, which just gave us a C linked list.o. So that's the object file it just created. which means I should now be able to compile my test linked list. Unless I have to do the exact same thing. I got to compile that guy separately. And then I can do a sudo gcc and now I'm not doing a compile only. I'm doing a taking my two object files and compiling them together, giving myself my a.out, oh, which I now removed a bunch of stuff from, right? This looks like it was going to work. Let me save that. So now I just need to recompile just test linked list. There's my 3. Can't believe that a modern GCC compiler would not auto-link. All right, so just to kind of explain what just happened, which just seems kind of ridiculous. I had to go and get my original link list and this guy right here. So I did a GCC -C on that guy. So GCC -help. It's going to be pretty early on in this. -C only runs pre-processed compile and assembly steps. So this doesn't actually try to link it into an executable. This gives us kind of a pod of all those things that I can then use to compile against for my future things. All right, so that's the first thing I did here. So I did gcc-c clinkList.c. So that created my low-level code version of that, but not as an executable. Then I was able to do the same thing with test linked list, which also gave me a .o file. Then I finally did a GCC with both of those .o files, and that created me my executable, which was my a.out, which then brought them together. That make sense? So I feel that if you did this in Cloud9, you might not have to do all those steps. I don't know if anybody was trying as we went along, but I'm surprised it doesn't auto-link. Okay, so then just for some more practice here, let's go ahead and for Friday, let's do add end, remove front, remove end. So we'll leave the remove from the middle stuff out, but let's just do some more practice. But let's separate it into multiple files like this. So we practice doing that. All right, so you'll have your linked list in one C file, and then your test in another C file, so you bring that stuff in. All right, but add 3 more functions. Add end, remove front, remove end.
Can I use an IDE to work the magic of compiling all this stuff?
Well, I don't care because you're just going to give me the source code files,
Yeah.
right?